Hi, and a warm welcome to this finalist presentation of the VUSec team for the Embedded Security Challenge of CSAW Europe 2020. My name is Marius, and I'm just the advisor of the team. The competitors and students who did actually all of the work are Enrico, Alyssa, and Hani, as seen here on the left in the slide. My role in here was basically just giving this presentation and doing a little bit of the organizational overhead. At this point in time, we solved the following challenges. As we see, only 5 from the release challenges are unsolved by now, and this still can change to the end of the competition, because we record this video before the actual end. So stay tuned, there may be more to come. I would love to talk about all the challenges we solved already, but unfortunately time is sparse for this presentation, so we thought let's just focus on the most interesting one from our perspective. So later in this presentation, I will talk about Amnesia and Corrupt. However, first, let's take a step back and think about how we got here. I mean, look at our office. It's empty. We are in midst of a global pandemic, and every one of us tries to work as much as home from possible. And as a result, in this office, all alone on a desk is the challenge board. To play the actual CTF, we hooked up this board to a shared server or shared computer, which we all could SSH into, and had a shared TMUX session, which will typically look something like this. On the top left, we have a GDB server. On the bottom left, a GDB client, which we would use for debugging. On the top right, Minicom, which would allow us to interact with, or not to interact, but to observe the serial output of the challenge buyout. And at the bottom right, we have Netcut, which would us allow to interact with the actual challenge. We would share this TMUX session and have it open at all times, and then have additional virtual meetings to talk about and play together, looking at those virtual shared TMUX sessions. With this session, we can play, interact, and so forth. However, we also needed a system to somehow organize our findings. And for this, we set up on the same machine a shared CodiMD, which is basically a shared Markdown kind of tool. You can imagine it a bit like Google Docs, just with support for Markdown. So we could enter code collaboratively and enter all our findings in there easily. Additionally, it has a nice overview over all the headings, and we used it to indicate which of the challenges we already solved and integrated into the report, as shown to the right. You see here already on this screenshot a little bit of the Amnesia challenges. So it's something about sysflash and saving and clearing. So let's look a little bit more in detail into this challenge. The general challenge works something like this. The board will boot and checks the flash memory for a specific key. If the right one is set, we will win, get the flag. However, this is not normally the case. So instead, what the challenge does, it saves the correct key into the flash memory. Then it sleeps for 4 seconds and blinks LEDs for a little bit, which we could not observe, unfortunately, as we were not in the office, and then overwrites the key in the flash with the YOLO. So what we did to solve this challenge, during the sleep, we basically reset the board. So this basically means that on the next boot, the correct key is still stored in flash memory. Up to this day, we don't know if this was the actually intended solution for this challenge, but we kind of liked it, and we were happy that we even could do it from remote without needing to press a button, thanks to the integrated JLake debugger on the board. And we really liked the challenges, or this specific challenge, because it brought back memories, specifically to Pokemon Gold and Silver, which had kind of a similar bug. You could specifically duplicate Pokemon by powering off the Game Boy at the right point in time, when you were basically after you transferred a Pokemon to a box and were saving the game. That being said, let's go on to the next challenge, which we really liked, Corrupt. Normally, challenges would come with one iHex file, which is used for flashing. However, this challenge came with 2. And as the name implies, one was corrupt. We could not use it for flashing because there were errors in the checksum. Luckily, we found a tool on GitHub to automatically fix those checksum errors into checksum.py, which made our life easier by far. After fixup, we could observe that this file would write a privilege level and a key to flash memory. And the other binary, the one which is not corrupt, would actually read this privilege level and take the key and check whether it's the right key and privilege level, as seen to the right here in the decompilation view from Ghidra. So the solution to the challenge here was to fix the corrupted binary, adjust the privilege level to be non-zero, and find the correct key. All of it with always fixing the corrupted binary to have the right checksums. This was really fun, and in the end it looks something like this. But time is almost over and we need to come to an end. So we first of all want to thank the organizers for organizing the CTF. It was a lot of fun, and we have just tiny bits of feedbacks, namely that we enjoyed most the challenges which had or which used the hardware components. Then that most challenges looked like reversing and crypto challenges, which is awesome on its own, but we also like to exploit things. So maybe next year there will be also some exploitation-based challenges. And lastly, there was a lot of frustration for one of our team members due to a challenge with not clear specified input formats. However, also here the CTF organization acted very good and fixed the challenge or gave an update to the challenge during the competition. So all in all, thank you so much, have a great day, stay safe and stay healthy. Thanks.